Evaluate the definite integral exactly. Here, notice that we have definite integrals. That means we're going to use the fundamental theorem of calculus of TC to evaluate these. So the FTC going to be definite integral from a to b f of prime of x dx going to be equal to b and a evaluated at the antiderivative f of b minus f of a. Here, of the definite integral from 1 to 2, 3x squared dx gonna be 3, and then multiply by the antiderivative of x squared. That's gonna be x cubed over 3, and then evaluate it at the limit of the integral. Now I'm gonna pull 3 out, so we have 3 over 3, which is gonna be cancelled and equal to 1. And then we have just x cubed, gonna just evaluate it at 2 and 1. That's gonna be equal to 2 cubed minus 1 cubed, which gonna be equal to 8 minus 1 and equal to 7. Notice that the resulting value of definite integral is just a number. Now let's try taking the antiderivative with a constant c. So this is the same definite integral, gonna be the 3, then multiply by the antiderivative of x squared. That's gonna be x to the 3 over 3, and then plus c1. That's gonna be evaluated at 2 and 1. I'm gonna pull 3 out, so I'm gonna multiply what's inside the parentheses by 3. So now we have 3c1, and then the evaluation gonna be the same. Note in here, I'm gonna assign 3c1 to c2, and notice here 3 over 3 gonna be equal to 1, so what's left off is x to the 3 and then plus c2, and then evaluated at 2 and 1. First, I'm gonna evaluate the term at x equal to 2, and then I'm gonna evaluate it at x equal to 1. Now I'm gonna move the minus sign that's between the evaluation to what's inside the parentheses, so it's gonna be minus 1 and then minus c2. Now notice that we have positive c2 and minus c2, that we're gonna result in 0 for c's, and we will end up with 7, which matches the same as in the top. So that's why we ignore the constant c when we use the fundamental theorem of calculus, since they will cancel each other.